We have all heard of the chemical element hydrogen before, most commonly in its gaseous state. Have you ever heard of metallic hydrogen?
Metallic hydrogen is exactly what it states, metal hydrogen. We already have hydrogen in two different states of matter, gas and liquid. For decades, it has been theorized that we can create hydrogen as a solid. It would be used as a possible source of rocket fuel and as one of the few superconductors of the world.
Let's go back to the beginning. The phase of metallic hydrogen was theorized way back in the 1930s by scientists Eugene Wigner and Hilard Bell Huntington. The first experiment on the route to this superconductive metal was shockwave compression in March 1996. With the use of 1960s era light gas guns and a measure of pressure at 140 GPa, it was stated that the first identifiable product of metallic hydrogen was created, but only for a microsecond.
Further experiments continued to proceed this first possible creation of metallic hydrogen through the years 1996 to 2011. All the experiments used static compression and low temperatures, and some included the use of pulsed laser heating. Scientists believe they were reaching pressures that nearly matched that of the Earth's core, but the hydrogen still wasn't a true alkali metal because of the non-zero band gap that remained.
Now, what is the band gap? It is the important trait of solid materials that determine whether they are insulators, semiconductors, or metals, conductors. The smaller the band gap, the more conductive the material, and the more metallic it becomes. So a non-zero band gap means that it still isn't a metallic material.
Finally, on the 5th of October 2016, Harvard scientists Ranger Diaz and Isaac F. Silveira released a statement saying that solid metallic hydrogen had been synthesized in their laboratory. In order to generate pressures greater than the Earth's core, a diamond anvil was used to compress the hydrogen molecules. The diamonds used to transfer the pressure were coated in alumina to help preserve them for longer.
The hydrogen was formed with a series of changes. At first, the sample was transparent, but when pressure was increasingly added, it then turned black, and then finally finished as a reflective metal. They did not continue with any tests, nor did they repeat their experiment, as this excess handling could destroy their existing sample. However, in February 2017, the diamonds within the anvil broke, which came as a shock to all, as diamonds are one of the hardest substances on this planet. This meant that the pressure applied was lost, and our only evidence of metallic hydrogen had disappeared.
The possibilities of mass production of metallic hydrogen would benefit this world immensely. One of its uses includes being used as a superconductor. A superconductor has exactly zero electrical resistance and is able to function at sufficiently low temperatures.
There is also the high possibility that metallic hydrogen would be used as a rocket fuel. It is more efficient and environment friendly, and a smaller volume contains much more energy than liquid hydrogen and oxygen, which are the current rocket fuels. This would benefit us future space exploration inside and outside the solar system.
If the world were to successfully create more metallic hydrogen, we would be able to do many things more efficiently and lives would be greatly impacted. We have started to build this bridge to the better future. Now we just need to safely cross it.